The volume of an object refers to the amount of space occupied by a solid object. The volume is measured three-dimensionally. When the polygon consists of multiple shapes, you need to find the volume of the individual pieces, then add them up. Or if you have one polygon inside of another, you need to find the volume of each part, then subtract them to get the volume desired. So let's look at a couple examples going over that. So we have this polygon here. I can see that I have a half sphere on top of a cone. So here is the formula for the cone and sphere, and I'm going to find out what is the volume for the whole thing. So let's start off with the cone. So the cone is 1/3 pi r squared h. So I need to know what r is, the radius, and I can see from here to here is 12, which means that the radius, must default to 6, because it will be half the diameter. So I know that r equals 6, and at the height of the cone, right here, even though it's turned upside down, but it's okay, is 15. So now I'm going to plug it in. So volume equals 1/3 pi times 6 squared times 15. So when I do that, I'm going to end up with 180 pi cubic centimeters. And I could multiply the pi out, but I'm going to leave it there for the time being. I'll deal with it later. Now I'm going to find the volume of the sphere. So again, I need to know the radius, which is 6. And now I can find the volume. So I'm going to have, let's see here, v equals 4/3 pi times 6 cubed. And when I do that, I'm going to end up getting a volume of 288 pi centimeters cubed. Now this is well and good, but I can see that I don't have an entire sphere up here. I have half of it. So I'm actually going to divide this by 2, and I'm going to get 144 pi cubic centimeters. So that is the volume of my sphere, half sphere that I'm given, and this is the volume of the cone I'm given. Now I can find the volume of the whole thing by adding it. So volume is equal to 180 pi plus 144 pi, and that's going to end up giving me 324 pi cubic centimeters. That's the exact answer, but if you wanted the approximate answer, I just used pi from my calculator, and I'm going to get to 2 decimal places 1017.88 cubic centimeters for the approximate answer versus the exact. Again, everything is cubic centimeters because we're in three-dimensional measurements. Now I have this shape here, which consists of a cylinder and a cone. So again, I'm going to find the volume of the cylinder, find the volume of the cone, then add them together to get the volume of the shape. So let's start off with the radius, because I need that for both. So the radius is going to be half of the diameter, so this is actually going to be 3 centimeters, so half of 6. So r equals 3. And the cylinder is 12 meters tall. So I said centimeters, I should have said meters. Apologies. And this should be the height right here. So I got everything I need. So volume equals pi times 3 squared times 12. I'll write it right here. Let's just keep it consistent. So the volume is going to be for the cylinder, keeping pi, 108 pi cubed, not squared, cubic meters. So the volume of the cylinder, 108 pi cubic meters. Cone, well again I can see that if this is 3 meters down here for the radius, it's also 3 meters up here. And the height is going to be a difference between 12 and 17. So this is actually going to be 5 meters. Keep it consistent. So the radius is again 3. The height is 5. Plug it into my formula. V equals 1/3 pi times 3 squared times 5. So the volume of this is going to come out to be 15 pi cubic meters. So now I have the volume of the cone. I got the volume of the cylinder. So now I'm just going to add them together to get the volume of the whole thing. So volume equals 108 pi plus 15 pi. And that's going to end up giving me 123 pi meters cubed. Or if you just put it in your calculator, if you don't want the exact answer like that, you're going to end up getting 386.42 cubic meters. How about this one here? We got an object within an object. So we got a rectangular solid, rectangular prism, and then we got a pyramid within it. So if we have a pyramid inside, how much area is left outside? So first off, I'm going to find the area of the volume of the rectangular solid, then the pyramid, and then I'm going to subtract the two. So again, I got length, width, height. So for the volume of the rectangular solid, it's just going to be volume equals 6 times 6 times 7, which means that the volume is going to end up being 252 cubic centimeters. Now I'm going to find the volume of the pyramid. I need to know the base. It's not given to me, but I can find it by multiplying the length times the width. That'll be 36, so base is 6 times 6. So the volume is going to be 1/3 times 36 times 7. And this is going to just come out to be 84 cubic centimeters. So that's the volume of the pyramid. I had the volume of the solid, the rectangular solid. Now I'm going to subtract the two to get the area with the pyramid's area removed. So volume is going to equal 252 minus 84, which is going to give 168 cubic centimeters. So if you have an object within an object, just like when we had two separate ones that were connected, just take the area of each one and then subtract it if one is within the other.